This is the second FRQ that we are going to be solved for the AP Physics 1 2026. So this is the official website that I taken it, so that we are going to be discuss it on the unit of the work done, energy and the power. So that is related to this question is. So the question is, let's come to the screen. So second question, I'm going to request to you, please go through that question for once more, and I will give the link in the description also of this question, or you can go to the official website and you can search it out. This is the AP Physics 1 Algebra Basic of the 2025, the free response question. So that is the question, the second question that we have it, that we are going to be solving. Let me highlight the few other things in this question. So there is a block that is x is equal to 0 at this is the position of the block. And so they are the marking on this inclined plane only. So this is the 4D, and up to the 8D, the spring is not stretched. So this is the unstretched position of the spring at this the 8D. And the as you release it out the block, as you know that when the gravitational potential energy convert to the kinetic energy, and at the this is the figure 2 in that they have shown it. So this is the image 3, and as you release it out, the kinetic energy first it convert to the kinetic energy. After that, as the spring will start compressing, spring potential energy gets stored into that. So this is the whole question is that we are going to be looking into that. So let me repeat once more. At x is equal to 0, they are going to be released it out. We have the gravitational potential energy, the basic idea that I'm giving to you, as it will convert to up to 8D, it will convert the gravitational potential energy, convert to the kinetic energy. After that, it will start compression. So as it will start compression, so the spring potential energy gets stored into the spring. So that is the whole scenario is that we have it. The first of the A part that they are telling it. So they have already given the energy block diagram for the at the position at the 10D. Remember it, at the 8D there is no compression. This is the unstretched position of the spring is. So at the x is equal to 10D means that the two block, so basically 10D. So this is the where the energy diagram that is they have given it, the block diagram that they given it. And the another thing is, so you release it out at x is equal to 0, and the block momently come to the rest. It is going to be come to the rest at the 12D position. It is going to be momently, it is going to be stopped. So it means that the all kinetic energy, all initially had the gravitational potential energy, that all gravitational potential energy convert to the at this point at the 12D, it is going to be convert that all of that energy into the spring potential energy. That should be clear in your mind. The thing is, remember it, the energy is always conserved, so it is a conserved quantity. So the total energy whatever that the system it have it initially, so the total energy going to be remain the same at every point. It is a constant quantity. So the thing is, so initially you have the gravitational potential energy convert to the uh, spring potential energy at this point, all that energy, but in between you have the some kind of the kinetic energy also. So they are the three things or three type of the energy that we are talking about. Gravitational potential energy come from the height. So if I quickly summarize that one, so we have the gravitational potential energy. So I'm going to write it UG with that one. So that is mgh. mgh. This is the change in the height. And one more thing that they mention it over there, the spring potential energy, they are taking it, the gravitational potential energy is the energy level at the 12D, they are taking at the zero potential energy level according to this diagram when they drawn it. So this is the change in the height. Gravitational potential energy always matter the how much the height is changed, not on the how much the sliding length. I will come to that point. So the height matters for that. Then we have the spring potential energy. I'm going to write it U. They have written with the US spring potential energy, that is the half. K is the spring constant, and the how much the length get compressed. This is the extension of the length. Extension, or in this case, it is a compression from equilibrium position. The equilibrium position is the we have the at the 8D. From the 8D, it will start storing the spring potential energy. Before the 8D, we do not have any kind of the spring potential energy because the spring is not compressed. Spring is when the spring is compressed, then only that energy is going to be stored, and that is the compression in the spring right now that we are looking for. Another one, we have the kinetic energy. Kinetic energy due to the motion of the object, that is half mv square. If we have the velocity, it has some kind of the kinetic energy. So simple, this is the energy conservation that we are going to be looking into that. Because the total energy of the system is always remain conserved. So they have already given the energy, individual energy bars at the 10D. So this is the kinetic energy, 7 E naught. This is, they have given the 2 E naught. So this is the 7 E naught kinetic energy. Gravitational potential energy at the 10D is 2 E naught. And here it is given the 3 E naught. Because the total energy, total always remain the same. E total is kinetic energy. K, they are going to be written plus UG plus US. And the total energy is 7 E naught plus 2 E naught plus 3 E naught. And that is come out to be 12 E naught. E total. Total energy going to be always remain constant. Now what we have it in the next part of the question is the P, and now you have to be make the energy bars at the x is equal to 0 and x is equal to 6D. So the point is at x is equal to 0, the block is only had the height, correct? So it is in the momentary at the rest. You are releasing from that one, correct? So now, so you had the only the all the total energy is due to the gravitational potential energy. So the total energy is 12 E naught. So it is also the 12 E naught. So you had to be make that bar here. So this is the potential energy that we have it. Now at the 6D, 6D is interesting case. So at the 6D, what is going to be happen? So at because we taken the 12D is the momentary at the stop, correct? So this is exactly at the half of the length of that. 12D, it is going to be stopped. At the 6D, it is just the half of the height. So this is the proportionality. You can think it like this. So whatever the height here, this is the same height here. So it is going to be lose the half of its in total whatever the energy initially, and this is 12, at this point it is 12 E naught, correct? So each unit decrease is going to be represent the E naught value. So E naught, E naught, E naught, because it is get decreased by the 6 E naught. But remember it, we are actually we look at the height, but they are proportional right now. The lines and something. So the every bit that you are losing, that every d distance that you are covering, that is loss of the E naught value. So this is going to be decreased by E naught value in each of them. So it is just left with the so the half of that, it is going to be lose in the kinetic energy as it will start moving. So and the half, it still it have the gravitational potential energy. There is no spring potential energy because the spring haven't compressed till now, correct, at the 60. So it is going to be covered like this. So I'm just making it fastly at the 6 and the 6. Remember it. The total energy in the system is the 12E note. It should be 12E note whenever that you make it, because the total energy of the system is always going to be remain the conserved. So this is the whole concept is. If you have still the confusion, please leave the comment. So now we are going to be moved to the next part of the question is. So the next part of the question is that state is in the figure 5 shows that the x is equal to block is x is equal to 0 and the block is released from the rest, and the block at x is equal to 12d when the block momently come to the rest against the compressed spring. So at this it is going to be. Now we had to do the drive the equation for the spring constant, that we had to be derive the relation for that. Again, conservation of the energy, total energy, look at the total energy at the x is equal to 0 and the total energy at the 12d. So that we are going to be make the equation is. Now let's total energy. So E total at this position is, so you have only gravitational potential energy, total energy. So the E total, by the E total is due to the gravitational potential energy, spring potential energy, and the kinetic energy. But you do not have the spring potential and the kinetic energy, you only have the gravitational potential energy at this point. The point is, the tricky point is, so they haven't given the height here. So I required that height first. I have to figure it out the height. To figure out, I can make the right angle triangle. This is the 12D. So let's make it separate. So I had to figure it out the height of that one. So the sine theta is equal to h by 12D. Opposite by hypotenuse. And then h values come out to be 12d sine theta. So this is the height of that come out to be, because I had to put it in the mgh. So let's mgh, h is nothing but that we calculated right now, that is the 12d sine theta. We had to be always look into the height for the gravitational potential energy. So this is the E total initial, can I write like this? Initial value, that one. But by the way, it is going to be remain the same. So E total final. Again, we are going to be look at this expression. So this one plus this one plus this one. Gravitational potential energy. So at the 12D, we are not going to be take any kind of the gravitational potential energy. This is the system has the 0, and we have the spring potential energy. Spring potential energy. So all that gravitational potential energy convert to the spring potential energy. And now we had to be look into the compression. How much the spring get compressed, because the natural length or unstretched position, so that is the 8d, and it compressed to the 12d as per the question is. So how much the length get compressed? So this is the 4d. So actually it is come out to be, and the spring potential energy is half spring k constant and the delta x, and the delta x, the compression is 4d square, plus kinetic energy is nothing because it is going to be momentary come to the rest of that one. So this is the, as we know that one, energy conservation. So the E total energy, that is going to be initial, whatever the total amount of the energy, it is going to be remain the same always. So let's plug in that one. So the mg 12d sine theta, it is going to become to the half k 16d square, and then you have to just reshuffle few things and you'll get your answer. So this is the k value that I get it. Please look into that if we haven't done any kind of the mistake in calculating that one or reshuffling of that. So this is how we are going to be calculate the spring constant value, and by simply conservation of the energy that we have it. And the next part of the question is in the figure number 6. So the energy of the system or the function of that. So they have given the spring potential energy curve, from the 8D. Remember it, it is from the 8D they are starting to the 12D. Because the spring get compressed, it will have, it keep on storing the some kind of the spring potential energy. So and it is curved. Why? Because it is half k x squared quantity. So it is have the, some kind of the parabolic curve as you can see it here. So the point is, so the block spring earth system they had taken it. So you had to be take the gravitational potential energy because the earth is taken as a spring, uh, taken as a system. We included that. So spring, we had to take the gravitational potential energy also in the count. First one is sketch and label the line to represent the total mechanical energy. Total mechanical energy is the sum of sum of gravitational potential energies and the kinetic energy. So it might be in this system. So we have the kinetic energy, we have the potential energy, but we have the two types of the potential energy: spring potential energy, gravitational potential energy, and the spring potential energy. So we have the two type of the potential energy that in the system we have it. So we had to take both of them here. So because as we know that one total mechanical energy is a conserved quantity, it never changes, so it will remain constant. So you can put it the straight line bar. They are going to be asked for you to sketch the line or a curve. So let's do that one then. So this is the E total. This is the E total. Then we have the sketch and the label of the curve represent the gravitational potential energy for the block of the earth, spring block spring earth system and something. So for that one, now they are we had to be make for gravitational potential energy, but this is the 8D. So at the 8D, what how much the gravitational potential energy is? As we stated before, every bit. So here to here, there are the 12D distance. Every d distance it is decreased, it will lose the 1 E naught gravitational potential energy. So 1, 2, 3, so it is overall 8. So out the 12 E naught minus 8D minus E naught, 8 E naught is the energy that is loses that because it come to the 8D unit down, 8D distance is covered. So it is directly proportional to the how much the length it is covered, correct? So it just left with the 4 E naught. Now you have to be make the from the 4 E naught is the just the gravitational potential energy is remained over there, and you have to be make the line from. So at this point, it will lose all the gravitational potential energy. So by the way, you do not have to be make that arrow. So instead of that arrow, you can remove the arrow. You can simply, because it is not a vector quantity, energy is a scalar quantity, just represent with the like this. So this is the curve for the potential energy that I had drawn. So this is the UZ. From the 4 you have to start. Now next part of the question is, next part of that, whether the speed of 9D of the block at x is equal to 9D is greater than or less than the speed at the 8D of the block. So the point is, they're asking for at the 9D, is it at the 9D or the 8D where the more velocity of the particle it is. The velocity is being calculated by the kinetic energy. So where the kinetic energy is greater, there only that you can say it, the velocity will be greater. So we have to be looking to the kinetic energy. The whole system had the total energy is conserved again. So we are going to be applying at this point. We do not have any kind of the spring potential energy. You have only gravitational potential energy. So this 8D, 8 E naught, sorry, 8e node is the kinetic energy at this point is you have the kinetic energy. Accordingly, you will get some kind of the velocity. Okay. So remember it. At this point, the kinetic energy at the 8d, the at 8d kinetic energy expression will be 8e node. Now, at this point, you have to be look the graph very carefully. This is not 1, remember it. This is slightly lesser than the 1. This curve is slightly lesser than the 1. This is exactly the 3 node. So this is not actually 4 in total. So if you look at this length is slightly more than the this. Basically, you have to add that this part, you have to add it here. So what I mean to say that because total energy is remains same. So this part is slightly like this that I'm making it. But this is slightly less than the 4e node. This part I added it here because the whole total potential energy and potential energy, total potential energy, whatever is the loss, gravitational potential energy, spring potential energy, the loss going to the kinetic energy, correct? So here we have the some kind of the spring potential energy, correct? So it is slightly lesser than the 1e node. So you have this at this, if I represent the green arrow with the kinetic energy, it is slightly lesser. So up to here, let me represent like this. This is the spring potential energy. This is the US spring potential energy. And this is the length is for the gravitational potential energy. And you had a slightly more at the 9D. So because the kinetic energy is more, the kinetic energy at the 8D is this much. But the kinetic energy at the 9D is more than the kinetic energy at the 8D. So basically it have the slightly the more velocity at the 9D. So the answer have to be, it have to be greater than that. And you have to give the justification for that. You have to look at the curve and then you have to comment. Okay, so this is all about this. So I'm going to make the few the other lectures on the FRQ series and it will continue this FRQ series. Thank you. Have a good day.